Hello, I'm Aalok Kafle, and in this project, me along with Rakshya, Reena, and Kushum, we are going to compare TensorFlow and PyTorch based on different criterias while we build same models on both of them. So regarding TensorFlow and PyTorch, these are two of the most popular open source machine learning libraries that is in use to train and test out the models. And PyTorch is developed by Facebook's AI research team, and TensorFlow, on the other hand, by Google's Brain team. And in this project specifically, we are comparing PyTorch's version 2 with TensorFlow's 2.1. And as we can see, when we look at the use, TensorFlow was previously in 2017 was being used far more than PyTorch, but as over the time, PyTorch has exceeded TensorFlow, at least in terms of Google search. This doesn't imply the direct use of those tools, but just an overview. And while we want to ensure a fair comparison between both TensorFlow and PyTorch's model, we are focusing on the following things. First of all, while we build models on both TensorFlow and PyTorch to compare, we're using the same data and the comparison will be made across the same data only. And when we build models, while we test models, we are keeping consistent conditions for both hardware and software. In case of software, we're using Anaconda for everything, Anaconda environment and Spider. And for consistent hardware condition, we're trying to maintain similar CPU uses, memory uses, and disk uses while we do that. So to compare them, we first made primary comparison criteria, the criteria being accuracy, model training time, and ease of use. So to compare our results using three criteria, first we conducted pairwise comparison between all three parameters using among our group, and then after doing that, we created this Perron-Frobenius matrix showing the pairwise comparison matrix data in a matrix format, and we use the ASP method to assign weights to each of these criteria.
Hello everyone, I'm Reena and I'm going to talk about our first model using MNIST DG data set. We use MNIST DG data set for training our model, since MNIST data set are used as a benchmark for training machine learning model. The MNIST DG dataset consists of 70,000 grayscale images of handwritten digits from 0 to 9, which has 60,000 images for training and 10,000 images for testing. The size of the image is 28 by 28 pixel, which is normalized and centered from NIST dataset. This dataset includes train images, train labels, test images, and test labels. So this dataset is trained using two libraries, PyTorch and TensorFlow, for comparison. We used same architecture for training both the model. We use feed-forward neural network. Then for flattening the input layer, we use 28 by 28 input size. Then we had two dense layers with 512 neurons, and for non-linear, for introducing non-linearity, we used ReLU activation function. Our output dense layer consists of 10 classes. Our output is a logit, and then for loss function we use sparse categorical cross entropy during training. Then for our iteration method, we use stochastic gradient descent optimizer for our MNIST dataset. Then for our own datasets, we use Adam gradient descent. We also used the same hyperparameters for both the libraries. Our learning rate is 0.001, momentum 0.9, weighting decay 0.001, and batch size 32. Our epochs were 10 for both the libraries, PyTorch and TensorFlow.
Hello everyone, I'm Kushum K C. I'll be continuing our projects on comparison of model and end-to-end model using TensorFlow and PyTorch. So for this, we use different data set. The first, we ran the same model for MNIST dataset, which is a digital image of handwritten digit from 0 to 9. Then we ran the model for different datasets. The first model comprises of the dataset of Texas Colbert, having like different classes for prediction of the Colbert condition. The second model was Ogulala aquifer data for fluoride prediction. And the third model was the compressive strength prediction model, and the fourth was the drought prediction model. And the classifications were either different classes, which is termed as the multinomial classification, or they were, for example, on model 2 and 3, they were like just classified into two different classes. And for the model 4, the classification number was used was 3. So discussing about the architecture of the coding, we tried to use the similar code for both TensorFlow and PyTorch, but the only difference is that in the TensorFlow, while defining the layers, the input shape and the activation functions, they could be used in the same line of code, but in PyTorch we need to define different function for taking the shape and the activation function, whereas we need to define the different function for input and output that will call that function of layer and activation function. And other difference is that in TensorFlow, we need to compile the model, whereas in PyTorch, we need to save the model in our device, and then we can run the model multiple times. So after running the model, we came to we get the accuracy of the model for training and testing dataset using the TensorFlow and PyTorch. So for the mean star MNIST dataset, it was found that the model we ran was more accurate for the TensorFlow than the PyTorch, and seeing for the model 1, 2, 3, and 4, the accuracy seems to reverse in model 3, which is the prediction of compressive strength.
Hello everyone, this is Rakshya Shrestha, and I'll be continuing the comparison of training data set by using different libraries of ANN. Yeah, for comparison, next we use training time. For training time, MNIST gave the for MNIST the PyTorch seemed faster. Trend faster by 11.81, but for other models, the TensorFlow came out to be faster. There can be several reasons, because for MNIST we use data loader, which was which did the iteration by itself and by taking epoch. But for other models, we did the iteration by looping ourselves. Like outer model was for outer loop we gave epoch as epoch, and for inner loop we gave iteration over each iteration of loop over each layer, which iterates over the batches. And for ease of use of comparison, the TensorFlow seemed easier, and because it was just one line of code for the same task as in PyTorch, it seemed less complex. And so for next we got the ranking from top 6. For that we took accuracy, modeling time, and ease of use. Accuracy and modeling time are the one we got from our got from training our model, training and testing our model. This is for training our model. Accuracy. So that the ease of use is how we felt flexible, all the team members, and we averaged it. And for MNIST dataset, we got TensorFlow as better library. And for also for own dataset, we averaged the accuracy for all the four datasets, and for model timing also we did average, and ease of users now we did ourselves for the flexibility. And so from that also we got PyTorch as second, and first TensorFlow as first. So this is a summary. In summary, the accuracy came out to be quite similar in both of them, with various varying result in different datasets. So TensorFlow is slightly faster than PyTorch, and for ease of use, code of TensorFlow is shorter, debugging is required because it's longer, more debugging on PyTorch, and resource finding was similar. So these are the model architecture summary. For MNIST, number of class was 10, and for others was 5 2 3. And for optimizer, we use stochastic data descent for MNIST and Adams for others. So this is a test size randomized and approach we took for our datasets, and these are the references. Thank you.